Ladies and gentlemen, welcome to the first Math 1B in Geometry video. We're talking about how to deal with graphing linear equations, and at the very end we'll talk a little bit about what it means to write them if you're given the graph. So let's hop into it. The reason why these are both for Math 1B in Geometry is we thought maybe it'd be a good idea to get geometry that algebra linear equation base that they learned from the previous course. So let's get to it. First of all, when you see an equation that's in slope-intercept form, so slope-intercept form is when you're isolating y on the left-hand side and you have the slope of a line, which is also the rise over run. We indicate it as m. All right, so m is equal to slope, which is the rise over run. Generally, we want to use it as a fraction, and it's always being multiplied by whatever x variable is in there. And then we add what we call the y-intercept. It's labeled as b. We've already got a y in our equation, so probably not a good idea to put another y. So b is the y-intercept. That's why it's called slope-intercept form, because it has the slope first and then the y-intercept. I also kind of talk about it as the starting point. It's the first point that you plot on the y-axis. And the bottom line is, like, what's the deal with an equation that's put in that format? So let's just take one like y equals 2/3 x, say minus 5. All right, so basically what you've got here is a relationship between x and y. And when you talk about a grid like this, the x is always mapping left to right. The y is always mapping up and down. So it's like saying a point that if I plug in an x here, so let's say I plug in x equals 1, 2, 3, 4, 5, 6. So if x equals 6, then my y value is equal to 2/3 times 6 minus 5. And if you remember your order of operations, you can take 6 times 2/3, which is 4, minus 5, you get -1. So the point 6, -1, so over 6 units, down 1 unit, that actually is a solution to this equation right here. A lot of times we don't talk about lines or points on lines as a solution to an actual equation, but that's exactly what we're talking about here. Furthermore, it's not just the point 6, -1. It's all the points on the line that has a starting point of -5. So 1, 2, 3, 4, 5 below the x-axis. Yeah. That goes up 2 units, right 3 units. So that forms a line when you go through it, and there's an infinite number of points on this line. All of those points are the solutions to the equation y equals 2/3 x minus 5. So maybe it wasn't necessary to go through that whole explanation of what's the deal with these equations, but I think it's important to keep in mind that this equation has a bunch of solutions. They're all the dots that create this line that's represented by the slope-intercept form given here. So let's get to some examples. I know that was a lot of abstract talking about it, but today is really quite simple. As long as you can find the slope and find the y-intercept in each of these equations that I give you, you're doing pretty well. So y equals 5 minus 2/3 x. Normally we want to write it as y equals mx plus b. So you can actually reverse the order of these. Just make sure that the negative travels with the 2/3. So it's -2/3 x, and then there's a positive 5 right there. Right here it's showing you that the plus 5 is our y-intercept. In fact, I'm just going to say b equals positive 5, just to keep things as clear as possible. Go up 1, 2, 3, 4, 5 units. And then you're looking at this negative 2/3. Now, the negative seems to be in front of the entire fraction. A lot of students have the question, is it negative 2 over 3, positive 3? Is it positive 2 over negative 3? Or is it negative 2 over negative 3? If there's a negative in front of the whole thing. Negative 2 over negative 3 is the same as positive 2/3. Because a negative divided by a negative is a positive. These both end up being okay slopes. Because down 2, right 1, 2, 3. Down 2, right 1, 2, 3. And we try to plot as many points as we can. Is on the same line as up to left 1, 2, 3. So, you really have two alternate choices for how you want to do the slope. Use a ruler to connect the dots. The line is kind of showing up there. All right, let's try example number 2. Everything seems to be in order. You got y equals 4/3 x minus 6. So the y-intercept is 6 below the x-axis. And the slope is 4 over 3. So you can just start at negative 6. So this is the x-axis. This is my y-axis. Down 1, 2, 3, 4, 5, 6. Plot a point. Then go from that point up 4 units, right 3 units. And I'll do it again. 1, 2, 3, 4 over 1, 2, 3. Take your 6-foot long ruler. And you got it. Pretty simple so far. Let's see if we have anything that's going to mess with our minds. Special cases, that is. Things we should look out for that could potentially trip us up. All right, in this next one, y equals 2 plus 4x. I see no fractions. That could be trouble. First thing I'm going to do is rewrite this so that the 4x is preceding the x, or I'm sorry, preceding the 2. So I'm reversing the order. And then I'm going to put a 1 under that 4. Because really my slope needs to be in fraction format to make sense of things. So m is going to equal the number in front of x, 4, but I'm going to place it over 1. The y-intercept is going to be positive 2. And if this is my x-axis, this is my y-axis, I'm going to start 2 units above the x-axis, and then let that go up 4 over 1, guiding me to my next point. 1, 2, 3, 4 over 1. Or this is the same as down 4, left 1. Down 4, left 1. 1, 2, 3, 4, left 1. I can do it again. 1, 2, 3, 4, left 1. This ruler is actually not working out so well, so I'm just going to freehand this one. You guys please use the rulers, though. All right. I would actually try 4 and 5 on your own right now. Pause the video. All right, you've tried 4 and 5. I do believe that this one, if any one of them caused you problems, this is the one. Because just like here was 2 whole numbers, you're like, okay, one of them's got to be a fraction. Well, what the heck do you do if both of them are fractions? Well, first I'm going to rewrite it in slope-intercept form. 3/4 x minus 4/5. And then you got to ask yourself, okay, what is the place where this thing's going to cross the y-axis? It's the number that you add to or subtract from the mx. y equals mx plus b. So the plus b is negative 4/5. So there's really nothing tricky about the identification of what's going on. 3/4 is the slope. But every time I tell somebody to plot this on the y-axis, they tend to do things like, oh, go down 4 and write 5 units. That's not on the y-axis. I have to plot a point on the y-axis to start this thing out. That's where you have to recognize that negative 4/5 is a number on the y-axis. It's negative 4/5 of 1 unit. So that's right above, okay, 0.8. It's like 0.8. 0.8 below the x-axis. So I plotted a point 4/5 of a block below the x-axis. Then from there, I'm counting up 1, 2, 3 units. Still, it's kind of in between blocks right now. And then write 1, 2, 3, 4. So it's got one point that's just slightly above negative 1. And then I got one point that's just slightly above 1, 2 units. And then I can reverse that again by going down 1, 2, 3, left 1, 2, 3, 4. And then I've got 3 points. Now, a line only requires 2 points to plot. I would like you guys to plot at least 3. So again, get your ruler, make sure it's a nice straight line. And that was the tricky part. You have to go through the y-axis at that spot. If it's a mixed number, a decimal, a fraction, that's the number it needs to cross over. All right, let's see how you did on number 5. I'm going to scroll down a little bit. Yes, so on number 5, there's only one number. It seems to be the number that's in front of x is what we always use for slope. So right away I can say our m is equal to negative 1/4. So wherever I'm starting from, it's going to go down 1, right 4, down 1, right 4, or up 1, left 4, up 1, left 4. If there's no starting point to speak of, they're just basically saying the mathematical number for nothing is 0. So 0 is the starting point. And that's only if you have an mx term. As you'll see that we have some special cases that require a little different thinking there. So this means we start at the origin. This is my y-axis. This is my x-axis. That's where it crosses. I'm going to go down 1, right 4. Plot a point. Then go up 1, left 4. Plot a point there. All right, on to special cases. Actually, I want to make this video less than 15 minutes, so I'm going to stop this one and then make a part 2 video that has all of our special cases and sort of like the second part of writing linear equations.